Section 4.2, our objective today is I can prove two triangles congruent by the side-side-side postulate, the side-angle-side postulate, and the angle-side-angle postulate. So if we have two congruent triangles, so triangle ABC is congruent to triangle DEF, then angle A must be congruent to angle D. Angle B has to be congruent to angle E. Angle C has to be congruent to angle F. And side AB must be congruent to side DE. And side BC must be congruent to side EF. And side AC has to be congruent to side DF. So angle A is congruent to angle D. Angle B is congruent to angle E, and angle C is congruent to angle F. So we know that three pairs of angles are congruent. We also know that segment AB is congruent to segment DE, and segment BC is congruent to segment EF, and segment AC is congruent to segment DF. And so in total, we have 6 pieces of the triangle that are congruent to each other. Okay? So we have 6 pairs of corresponding parts. Now it turns out that we don't need to know all 6 things to know that triangles are congruent, okay? But before we get to that, we need to know something about the terminology, okay? So if I have, let's say, triangle XYZ, okay? Then if I want to focus on this side, that side is opposite angle Z. Okay? So I can say segment XY is opposite angle Z. So in relation to the triangle, Z is opposite side XY. Okay? By the same token, I know that side YZ is opposite angle X. Okay? So we have that idea. Okay? We also have the idea of the included angle, okay? So for instance, if I look at this side and this side, so those two sides form angle X. So we would say that angle X is the included angle, okay? So angle X is the included angle between segment XY and segment XZ. Okay? And so we would talk about side, angle, side, because that is the included angle. Okay? So if I had this triangle and I was talking about angle Z, then angle Z is formed by this and this. So angle Z is the included angle there, and it is included between side YZ and side XZ. Okay, so this is side, angle, side. So angle Z is the included angle between segment YZ and segment XZ. Okay? So it's important to be able to identify the included angle. That's the key word here. The included angle. Okay? We also have the idea of the included side. Okay? So in the included side, we focus on two angles. So for instance, if I have angle Y and angle X, the side that they share is XY. So that's the included side. So notice that I have angle, side, angle. Okay, so we would say that segment YZ is the included side between angle, I'm sorry, it should be YX. Angle, I'm sorry, side YX is the included side between angle X and angle Y. Okay, so notice that the included side has to be a side of both angles that we're talking about. Okay, so if I was talking about angle X and angle Z, the included side would be XZ. So segment XZ is the included side between angle X and angle Z. So notice again that we're talking about, here's an angle, side, angle. Okay, so it's important where it is. All right. Now, in order to prove triangles, two triangles congruent, we're going to look at three postulates. The first one is called the side-side-side postulate, and it says if three sides of one triangle are congruent to three sides of another triangle, then the triangles are congruent. Okay, so this first postulate tells us that we don't need to know all six parts of the, or all six pairs of the parts of the triangle, corresponding parts of the triangle are congruent. We only need to know about the three sides. So if this is triangle A, B, C, and triangle D, E, F, if I know that AB is congruent to DC, DE, and BC is congruent to EF, and AC is congruent to DF, then I can say triangle ABC is congruent to triangle DEF. Okay, so it's sufficient to know that all three corresponding sides are congruent to say that the triangles are congruent. Okay, now the other two postulates require the included angle or the included side. So the first one is called the side angle side postulate. because this one requires the included angle. So it says, if two sides and the included angle of one triangle are congruent to two sides and the included angle of another triangle, then the triangles are congruent. Okay, so this one is saying if you have two triangles okay, and I know that BC is congruent to EF and AC is congruent to DF, and the included angle or the included angles are congruent, then I can say the triangles are congruent. So if this is congruent to this and this is congruent to this, and the included angle, in other words, the angle formed by those two sides, if those two angles are congruent to each other, then I can say triangle ABC is congruent to triangle DEF. Okay, so it's sufficient to show that those three specific things are congruent, but it has to be those three specific: the corresponding sides and the included angle in those two corresponding sides. And then the final postulate for today is the angle side angle postulate. So this one uses the included side. So it says if two angles and the included side of one triangle are congruent to two angles and the included side of another triangle, then the triangles are congruent. Okay, so in a picture, okay, so two angles, so let's say it's this angle and this angle is congruent to this angle and this angle, and it has to be the included side, which would be this side and this side. So if that is true, then I can say triangle ABC is congruent to triangle DEF. Okay, so let's look at some examples here. Okay, so the question is, can the two triangles be congruent? And if they are, what is the congruence? So number one, so if I have this is SPO, are. And I know that this is congruent to this, even though my picture doesn't look like it, and this is congruent to this. Can I say that the two triangles are congruent? Well, we have this side corresponds to this side corresponds to this side, and by vertical angles we can say that this angle is congruent to this angle. So by the side angle side postulate, we can say that the two triangles are congruent. So we can say that triangle POS is congruent to triangle TOR. Okay, and that is by the side angle side postulate. Okay, example 2. Okay, so in this one, I have this picture. This is A, B, C, and D. And I know that this is congruent to this, and this is congruent to this. Okay, so I know that this corresponds to this corresponds to this, and by the reflexive property, this corresponds to this, and it belongs to both triangles. So by the reflexive property, I can say that that is congruent to itself. So then I can say that by the side postulate, I can say that triangle ABC is congruent to triangle CDA. Okay, because if you kind of picture this triangle being turned, this vertex would line up right here. Okay, and so this would match up with that. So you can see that those would be congruent. Okay, number 3. So if I have this triangle, which is PQR, and this triangle, which is TSU, and I know this angle and that angle are right angles, and I know that this angle is congruent to this angle, and I know that this side is congruent to this side. So here we have this angle congruent to this angle congruent to that angle, and this is the included side. So by angle side angle postulate, we can say that the two triangles are congruent. So we can say triangle RQP is congruent to triangle UTS. Okay, because remember that you have to list them in corresponding order. So R corresponds to U, Q corresponds to T, and P corresponds to S. Okay, and our last example like this is example 4. So I have this picture, and this is E, F, G, and H. And in this picture, I know that this is congruent to this, and this is congruent to this. Okay? All right, so in this one, well, we could say by the reflexive property that this is congruent to itself. But notice what I have there. So I have, I have this and this, but I don't have the included angle. So in this one, there is no conclusion. Okay. In other words, we cannot say that the angles are, or the triangles are congruent, because we don't have the correct correspondence. So we don't have side, 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 we don't have side, angle, side, and we don't have angle, side, angle. So we can't say that they're congruent. Okay. So let's do another example with a proof. So given that segment DC bisects segment AB, and that AC is congruent to BC. Prove that triangle ADC is congruent to triangle BDC. And our picture looks like this. This is A, this is D, this is B, this is C. Okay, so in this one, first of all, we know that segment DC bisects segment AB. That's given. Okay, so this bisects this. So what does that tell me about the picture? It tells me that AD is congruent to DB, okay, by definition of segment bisector. So we can say then that segment AD is congruent to segment DB by definition of segment bisector. Okay, we also know in the given that AC is congruent to BC. So we know that this is congruent to this. Okay? And we know that because it's given. Now we only have three ways to show the triangles are congruent. We have side, 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 angle, side, or angle, side, angle. We don't know anything about any of the angles. But we do know that DC is congruent to DC by the reflexive property. Okay, and then we know that corresponding sides of the two triangles are congruent. So then we can say that triangle ADC is congruent to triangle BDC by the side, side, side postulate.